Okay, so this is questions J, K, L from that radical review sheet. Okay, so what we can do is much like question I can just distribute the root 6 into the brackets for this part, right? So what I'm going to see here is root 6 times root 2 is going to be the square root of 12 plus, when I multiply two things with the same radicand together, it actually just spits itself out to be just 6. For the reasoning, if I had x, square root of x times the square root of x, and I had, this is the same thing, which we're going to look at in this course as x to the 1/2 times x to the 1/2, we would have learned in grade 9, way back when, that when I have things of the same base, in this case x is the base, and I multiply them together with an exponent, I end up adding the exponent. So this is actually 1/2 plus 1/2. So we get x to the 1. Okay, that's the reason why root 6 times root 6 is just 6. Okay, and so we get, if I was to finish this question off, I'd get the root of 4 times the root of 3 plus 6. It's 2 root 3 plus 6 should be the answer for that one. Okay, so let's jump to K. Root 2 times root 3 is going to be root 6 plus 4 root 2. I don't think there's anything to be done there. That's it for that one. Okay, the last one is a grade 10 question. Specifically something that would be like x plus 4 times x plus 6 or something, right? We've seen something like this before, right? Where we call this foiling, or kind of the rainbow method, if you will, where we're kind of taking root 5 times root 5, root 5 times 3 root 6, and then root 6 times root 5, and then root 6 times 3 root 6. Okay, so that's all we're doing. Root 5 times root 5 is just going to be positive, like just 5. Root 5 times 3 root 6 is going to be plus 3 root 30. Okay. Root 6 times root 5 is going to be plus just 1 root 30. And then root 6 times 3 root 6 is going to be plus 3 times 6. Okay. So let's just clean this up. We'll do a little collecting of the like terms in the middle, if you will. So we're going to get 5. And then I can also bring that 3 times 6 down here. So 5 plus 18 plus 3 root 30 plus root 30. And so we're going to get 23 plus 4 root 30s. Okay. Now, nothing to be factored out. This tricky one at the moment is the square root of 30. But if I run through, okay, just as a check, if we're checking whether or not we can simplify anything, we're trying to divide 30 by all those perfectly squared numbers, right? So something like 30 by 4, I don't think goes in evenly. Okay. 30 by 9, not going to go in evenly. 30 by 16, not going in evenly. 30 by 25. I don't think there's any combination of radicals where one of them is perfectly square rootable that we can simplify the square root of 30. So I believe that that is as simplified as we can get it. Okay, so that is questions J, K, and L off of that review sheet for radical.